Welcome back. Let's round up this chapter number 7 of CCNA CyberSecurity Operations with me, Joachim Kjevrestad from the University of Skövde. And in this chapter we will go through the part that is called attacking what we do. It's more different types of attacks and vulnerabilities, really. So let's talk about ARP vulnerabilities first. And remember that hosts broadcast ARP requests to find the MAC address of destination devices. So a device knows the IP address of a package of the host where it wants to send some package, and it knows that it's on a local network, so it will do a ARP request to find out the MAC address of this recipient. So hosts can also broadcast something that is called gracious ARP, and this is basically an ARP reply that they send even though they didn't get a request, and they send it when it boots up. And basically this is to inform the network about their existence. And this is kind of nice because when they do that, all the other hosts can add a new host to their MAC address table and basically know about it, so they don't have to send out ARP requests when they want to communicate with it. The thing here is that an attacker can try to hijack IP addresses by sending out multiple of those gracious ARPs, and then they can pose as the real computers and perform a man-in-the-middle attack to, for instance, its attempt to be the recipient of data intended for the default gateway. So they basically try to hijack the MAC address of the default gateway, and then computers that want to communicate with the internet will send the data to the malicious computer. Another attack we can do against ARP is ARP poisoning. And ARP poisoning is basically an attack where an attacker attempts to give network devices incorrect ARP information. We call this ARP cache poisoning. We can either do it passive or active. And passive ARP poisoning is when the attacker attempts to steal confidential information. It can, for instance, do this by trying to pose as the default gateway to have all devices send the data through it. It can also do active ARP cache poisoning, which is when the attacker tries to modify data and transfers it or inject data. So quite easy. Passive is when we try to steal or look at information, and active is when we try to modify the information. So let's move on to some DNS attacks. DNS servers are for some reason usually or quite commonly overlooked when it comes to security. There are many open DNS servers, such as Google DNS, that is widely used. The IP address is 8.8.8.8, and anyone can use it as a DNS server. Those open DNS servers are called open resolvers. And open resolvers are vulnerable to a number of activities, malicious activities that include DNS cache poisoning, and this is an attack where the attacker sends falsified resource records to the resolver. Basically gives incorrect information. So, for instance, one may do an attack where we locate a bank like Swedbank, one of the Swedish large banks, and then we poison a DNS cache with falsified information about the IP address of the Swedbank webpage, and then we use that to redirect users to a falsified version of Swedbank that we can use to steal banking information. DNS amplification and reflection, and this is when open resolvers are used to increase the volume of an attack and hide the true attack source, sort of as we saw with the ICMP amplification and reflection in the last lecture. And we also have DNS resource utilization attacks, and this is an attack where the attacker basically consumes all open resources of the open resolver, and that makes it unusable for anyone else. So, for instance, the Google DNS is widely used. If someone carried out a successful resource utilization against Google DNS, all users of Google DNS would be unable to surf internet as it's intended. There's also a number of techniques an attacker can use to leverage DNS to hide, and this is perhaps not a complete list, but some examples are fast flux, and this is a technique used by phishing and malware delivery sites, and it usually hides the phishing and malware delivery sites between a quickly changing network of compromised DNS hosts. So it's basically an obscurity approach where you quickly where you quickly modify the data in different DNS hosts, making it very hard to track your true whereabouts. Then we have the double IP flux, and this is the technique where the host name IP binding is rapidly changed to avoid the detection. So you basically run over different host names and IP addresses. And then we have various domain generation algorithms, and those are techniques that are used to randomly create domain names, and those are used as rendezvous points for command and control servers in, for instance, botnets. We can also mention the technique DNS tunneling. And DNS tunneling is basically about tunneling non-DNS data in DNS traffic. And this is quite well used, since DNS is often overlooked in terms of security. And this can, for instance, be used by a botnet command and control device to send command and control traffic to bots. So you use the DNS protocol to send commands to your bots to, for instance, start an attack. Let's move on and talk about one common attack in DHCP when it comes to DHCP servers. So remember that DHCP is used by new clients to request IP information from a DHCP server that's on the network. The DHCP server will send out a request package that is sent as a broadcast, so anyone on the local network can receive it, and it will just wait for IP configuration from a DHCP server. One way we can leverage how DHCP works is that as an attacker, we can, if we have physical access to a network, we can create our own DHCP server within the network, and we basically respond to DHCP offers that contain the IP configuration that we want the client to have. So this is, for instance, a way to configure the client to use a malicious device as the default gateway. And if we act as a man in the middle and just snoop up the packages that the client sends, we can just snoop up the packages and send it away to the true default gateway. And it's a very high chance that we can listen in on network traffic without the device actually even knowing about it. And this is a very possible attack due to the fact that, well, the DHCP client that requests the address doesn't really know what server to expect a reply from, so he will be happy with anything. And if we give him useful information that appears to be normal, then, well, he will use it and be happy with it. So let's talk about some web-based stuff, beginning with HTTP and HTTPS. We cannot really turn off the web, even though there are a lot of known web-based attacks that happen all the time. So instead we need to know about those attacks and know how we can try to avoid being compromised. So some common attacks include that a compromised legitimate web page redirects users to hacker-controlled web pages. So, for instance, if we take the banking example again, an attacker wants to have users wants to get banking information from users. So what they do is that they compromise a bank website, and they make sure that users of that website gets redirected to a hacker-controlled copy of the banking website, and then as the customers input their information, the attacker will steal it. There are also malicious sites that take advantage of, for instance, vulnerable browser plugins to compromise the client system. So you may set up a web page that uses some vulnerability in a browser plugin, and if a user that has that plugin comes along, then some malware will be downloaded to the computer, for instance. So we've discussed HTTP transactions in quite a great detail before, and understanding those and also reading log files is a very good key in trying to detect web-based attacks. Let me just talk for a second about email. Email is an essential service in any organization, and again, there are email-related attacks. I guess we all know about spam, that may be rather harmless but annoying. We have phishing, where attackers try to make us do things we shouldn't really do. We have attachment-based attacks, where attackers send us malicious stuff as attachments. We have spoofing, which is a technique where the attacker uses a spoofed sender address, so they spoof the address to pose as someone that they are not, and this is often used in combination with one of the other attacks. And There is also something called open relay mail servers that are out there on the internet, and if those are poorly configured, then the attacker can use them to relay spam messages. So let's begin to round off with web-exposed databases. So web applications often use databases to store and retrieve information. So for instance, if there is a way to register as a user or for a web for a newsletter or whatnot on a web page, there is usually a database that stores this information. Unless those database connections, the code that transfers whatever we type into the form into an SQL or database query, unless those are secured, we can be targeted with injection attacks. And there are basically two different main forms of injection attacks, where the first one is command injection. And command injection is where vulnerability is exploited in order to execute commands in the underlying operating system. So remember that we talked about command chaining in the Linux part. You most likely don't, but we did, which is about chaining different commands, so you execute many commands in one row. Let's say we have a web function that in the end executes some command. Then we need to stop an attacker from using that and using a command chaining technique to, for instance, inject something that discloses or removes data. We have SQL injections as well, and that is basically the same, but instead of trying to inject operating system commands, the attacker tries to inject some arbitrary SQL strings. So for instance, instead of just allowing whatever form we fill out to store a user, we also try to inject some SQL code that makes the database disclose all the passwords that's stored within the database or something like that. I also want to mention cross-site scripting, and cross-site scripting is when web pages that are executed client-side are injected with malicious scripts. So this script can be used by, for instance, Visual Basic or JavaScript to access a computer and get sensitive information. And there are two main types of cross-site scripting, beginning with store. And those are scripts that are permanently stored on an infected server and then received by all the visitors of that server. And then there is reflected, which requires that the malicious script is located in a link. So there is a script somewhere on a web page, and if a user clicks or a visitor clicks on that link, then they are infected with this script. So how do we avoid injections? Well, use input validation. Yes, use input validation. So whenever we have a situation or a function where the user inputs data to our website, make sure that the user can only input the input that we expect. So if the user should input a string, make sure that it's just a string and nothing else. If the user should input an email, make sure that it's an email and nothing else. And there are also some different key characters that you can just forbid because they are usually used in injection attacks, including for instance semicolon, the pipe sign, stuff like that. We could also use intrusion detection to detect malicious scripts, use a web proxy to block malicious websites, and of course educate end users to make end users aware of security and security threats. So that in a rather rapid pace ends chapter number 7, and we'll be back next time with chapter number 8. So until then, feel free to leave questions in the comments field, and I will get back to you soon.